The point-slope form of the equation of a line. The first thing I'm going to do is derive the equation. Then I'll give you two examples, one using a slope and a point, the other just using 2 points. So first, to derive this, let's go back to something you do know. All points on the coordinate plane have the form of xy, where there's an x coordinate and a y coordinate. If I want to refer to a specific point, like point 1, I might call it x1, y1. And a different specific point, point 2, x2, y2. Those are points. The top one, the point xy, is any point in general, and the bottom two are specific points, even though I don't know exactly what the numerical values of the variables are. Any case, recall, based on this, that if I take the change in rise over the change in run, I get the slope. Now, if I were to take this equation and multiply both sides of this equation by the denominator, what's going to happen? Well, the denominator will cancel over here, and the other side will just stay the same pretty much. So I'll get y2 minus y1 equals the slope, x2 minus x1. And I'm going to do one further change. Instead of referring, as I have right now, to a specific point, I'm going to change that to any point in general. Y minus a specific y equals the slope, x minus a specific x. So notice this equation that I've just derived comes directly from the definition of slope. It is nothing but the definition of slope in a slightly different form. Uh-oh, where'd it go? Do you remember what I said? It was nothing but the definition of the slope in a different form. The different form being y minus y1 equals the slope times x minus x1. So for the first example, where I have a point and the slope, what if I tell you the slope equals 4, and the point that this line goes through is the point 7, 3. What is the equation of the line with a slope of 4 and traveling through the point 7, 3? Piece of cake. All you have to do is plug and chug. Y minus my specific y equals the slope times x minus the specific x. Done. Woohoo! You don't have to do anything else to that. You can leave it. You're done. All right. I said I'd give you a different example. Example 2. Here, instead of a slope and a point, I'm going to give you 2 points. The point 4, 3 and the point 7, 5. Uh-oh, we can't just plug and chug. Uh-oh, SpaghettiOs. No, we have to do something first. We have to calculate the slope first, because we don't have the slope. So the slope, remember, y2 minus y1 over x2 minus x1. Okay, just now I can plug in numbers. The second y, 5, minus the first y, 3. The second x, 7, minus the first x, 4. 5 minus 3 is 2. 7 minus 4 is 3. Oh, look at that. A slope of 2/3. M equals 2/3. I wonder why they chose M for slope. I have no clue. Why M? Any case, the slope is 2/3. Now, for the second example, which point do I have to pick? Does it matter? No, it doesn't matter. I can choose either point. Just for, oh, the fun of it, I'll choose the first point. Y minus the specific y of 3 equals the slope. We calculated that. 2/3 x minus the specific x of 4. Yeah. That's it. There's the equation of the line. Okay. I'll do it. I'll use the other point. Alrighty then. Y minus the specific y equals the slope. X minus the specific x. Woohoo! Hey, are those really the same equation? I mean, I really don't have to, they don't look the same. And I don't have to change anything. They're the same in that they have the same slope, but they go through 2 different points. So are they really the same equation? Hey, where'd they all go? Wait a minute. Give me back my equations. Where are my equations? Ah, there you are. I was wondering where you disappeared to. Any case, let's just change the form of these again. Normally, you don't have to do this, but I'm merely doing this to show you that these two really are the same equation. The first thing I'm going to do is distribute the 2/3. So y equals 2/3 x minus 2/3 of 4, leaving the y minus 3 alone. Okay, what's 2/3 of 4? Oh, that's 8/3. Y minus 3 equals 2/3 x minus 8/3. Okay, I have to add 3 to both sides. Y equals 2/3 x minus 8/3 plus 3. Wait a minute. What's fraction action? Y equals 2/3 x minus 8/3 plus 9/3. Negative 8/3 plus 9/3. I think that's 1/3. Y equals 2/3 x plus please, 1/3. Oh man, I hope the blue one, I hope the equation on the other side comes out to be the same thing. So, I'm going to distribute the 2/3 into the parentheses, giving me a 2/3 x minus 2/3 times 7. 2/3 x minus 14 over 3. The other side, I got to bring down just for the fun of it and come along for the ride. Okay, so I've distributed the 2/3 in. Add 5 to both sides. Y is equal to 2/3 x minus 14/3 plus 5. Okay, I know this is fraction action. Y equals 2/3 x minus 14/3 plus 15/3. Hey, it's going to work. Woohoo! 2/3 x plus 1/3. Notice if I put them both in the slope-intercept form, I get the same slope and the same intercept. Now remember, normally you don't have to do it. The problem's done. You can read the equation of the line perfectly well off the point-slope form. See, from this equation, you can read one of the points and the slope. Oh, it disappeared again. Okay, recap and stretch. The point-slope form of the equation of the line. Y minus a specific y equals the slope times x minus a specific x. Here you know a particular slope and a particular point that the line goes through. This is nothing but a rearrangement of the definition of slope. Okay, your turn. Here's an equation. Y minus 4 equals 2/7 x plus 2. Tricky. What is the slope? What point does this line travel through? That's example 1. Or try on your own one. Try on your own 2. Here's a slope. And a point. And your job is the equation. Now, do not go into the slope-intercept form. Use the point-slope form only. So give me that equation. And don't go skanking off into old habits. And finally, I'll give you 2 points. The first point I'm going to give you is 3 comma negative 5. The second point that I'm going to give you is negative 3 comma 7. Now, you have to give me the equation given those 2 points. And again, as I said before, point-slope form, not slope-intercept form. No old habits. Ciao for now.